everyone. Today we're looking at Unit 7, Lesson 2, Surface Area of 3D Shapes. So I just wanted to show you, and this formula sheet is on our online Brightspace classroom. Today we're looking at surface area. So there are a number of real-world applications involving the surface area of 3D objects. So to find the surface area, we're going to add the area of all shapes. So add the area of all shapes. And to determine how many shapes there are in a 3D shape, we often will kind of split the 3D shape open theoretically and try to lay it flat on the page to make a two-dimensional flat shape, which is called a net. So for instance, if I was to look at this rectangular based prism here, and we were to slice it open and lay it flat, which of the 2D shapes that you see below would it line up with? And hopefully we can all see that this would line up with this, right? If we were to cut it open and lay flat. Our next shape here, we have a triangular based prism. And if we were to cut open, let's say like along this, and then lay it flat on your desk, hopefully we can all see that that would end up looking like this one here. Okay, our pyramid here would look like this. And this shape here is called a cylinder. That's going to look like that if we cut it open and lay it flat. So that's just the idea of laying a 3D shape flat to make its appropriate net. So we're going to kind of look at that when we're finding the surface area. So for example, if we were going to find the surface area of this is called a triangle based prism. Okay, we could use the net. We could also just look at the formula on the formula sheet. I'm going to use the net to start, and then we can kind of use the formula sheet going forward. I just want you to understand where it comes from. So I can see here that I have 1, 2, and then 3 rectangles. So I'm going to draw those 3 rectangles. And then off the sides of one of those, depending on, I guess, where you cut it open, you're going to have those you have 2 triangles here. This one here, and you got this one here, and it looks like they're right angles. So I'm just going to draw to the best of my ability those 2 triangles. It's a hard time looking like a right triangle. Okay, and the side lengths of those triangles, because we can see there's little tick marks there, they're the same, okay, and those are 5 centimeters. 5 centimeters. And those are also the lengths of my rectangle. So if we wanted to find the surface area for this whole thing, we have to add up the areas of each of the shapes. So add up the areas of this rectangle, this rectangle, this rectangle, and then add to it the areas of our triangle. So we have to remember those formulas. So the formula for area of a triangle is base times height divided by 2. Well, I have 2 triangles here, so I'm going to do 2, and then in parentheses I'm going to go base times height divided by 2. And then for our rectangles, well, for us, they're all the same, so we're going to do 3 times length times width. All right, so my base is 5 and my height is 5. So I'll have 5 times 5 divided by 2 for those triangles. And same thing with our length and width, both 5. I'm going to run out of room here. So those 2's cancel out, you're just left with 25 plus 5 times 5 is 25, 25 times 3 is 75. So you're going to have 100 centimeters squared for that. And I just want to, again, shoot over to that formula sheet for that next example. So we have a cylinder here. Oops. So we're going to use that surface area formula we just got from our formula sheet. So it was 2 pi r squared, right, because we have 2 circles. and we're going to add to that the area of our curved side, which is 2 pi RH. So we got to figure some of this out. So this is my height here. And then your diameter of each of those circles is 8. So our radius is going to equal 8 divided by 2, which is 4. So I'm going to plug in these values that I've just found. So r is 4 squared plus 2 times pi times 4 is for my radius, and my height is 8. Okay, so if you were to calculate these, I'll calculate them one at a time, or at least these groupings together. So 4 squared is 16, 16 times 2 is 32, and 32 times pi, make sure you know where your pi button is on your calculator, is approximately 100.5. Okay, if we calculate over here, we have 2 times 4 times 8, which is 2 times 4 is 8 times 8, 64, and then 64 times pi is 200.8. So the surface area is going to equal 301.3, and this was in inches, so inches squared. Okay, so let's look at some word problems as they relate to surface area. But this form, so how much corrugated aluminum will it take to construct the silo? So hopefully when we think about that, the corrugated aluminum is what we're wrapping the silo in. So what's going around it? So that's going to represent, again, our surface area. All right, so in this case, we just have a composite shape like we did with those 2D shapes. So we're going to need to find the area of both things and then add them together. So first things first, we have half of a sphere here. So we need to know the formula for surface area of a sphere. Okay, and if you look on your formula sheet, you're going to see that that is 4 pi r squared. All right, and then we're also going to need, I'll do a different color, the surface area of the other shape that makes up this silo, which is my cylinder here. So we're going to need to know that as well. So surface area of a cylinder, and we saw that on the previous part of the note, was 2 pi r squared plus 2 pi r h. Okay, so let's see if we can't plug in some of this formula. But the thing to remember about this sphere here too, we'll plug in our radius. So 4 pi, my radius, make sure we draw attention that this is our radius of our circle. 4 pi and then 10 squared. But we only have half of a sphere, so we're going to divide that by 2. So if you calculate that, all that, you should get 628.3. Okay, so if we go to plug into this surface area of a cylinder now, we have to take into consideration that for this cylinder, we only need our bottom circle and that lateral side, right? That's when you take the surface area, because we're wrapping the outside of the silo in aluminum. So we don't need this top circle here. We don't need to calculate the surface area of that because the inside part, that top part of that cylinder, won't be covered. So essentially, we don't need this 2 here, right? We only have one circle to wrap in aluminum. So if I was going to rewrite this, I would rewrite it with just pi, and then our radius is 10 squared plus 2 pi times my radius of 10 times the height of 16. Okay, and if we simplify, we're going to get 314.7 plus 1005.3, which equals 1319.5. So then total surface area would just be the sum of each of those individual surface areas. So 628.3 plus 1319.5, which equals 1947.8. And this is in feet, so feet squared. So we could say, therefore, it will take 1,947.8 square feet of corrugated aluminum. Okay, let's look at one more example. So you've been commissioned to design a door for a washing machine. The door of the washing machine will be a square that measures 22 inches by 22 inches with an area cut out for a circular window with diameter 8 inches. The depth of the door is 3 inches. Determine the surface area of the door of the washing machine to the nearest tenth of a square inch. So let's start with this one by drawing a picture. So we have a washing machine door, all right? It will be square. So let's draw the square. All right, and it's going to be 22 inches by 22 inches. It's going to have an area cut out for a circular window with a diameter of 8. So we're just going to draw a circle in here. Okay, and that diameter across it will be 8 inches. And then it says the depth of the door is 3 inches. So if we're just going to try to make this three-dimensional, do something like that. Okay, and then this will be 3 inches the depth. So we just need to consider that we have this glass door, or glass window rather, that is being cut out of the door. So it'll be on the front of that washing machine door and on the back side of it, okay? So you'll have those two circles essentially that you have to subtract out from the surface area being found here. So we have to look at the surface area and how we're going to calculate this. So within this shape, we have a square at the front that's going to be 22 by 22, right? And that same square is going to be at the back. And then along the sides, we have a square that's, or a rectangle rather, that's 3 by 22. And then we have it on this side, and you'll have it on the other side and on the bottom. So you'll have 4 of those, okay? And then the last thing we have is we have these circles at the front and back of the shape that are going to be cut out from that rectangular base prism, basically. So if we're trying to find the surface area, we are going to have 2 squares that are 22 by 22. And then we're going to have 4, so we're going to add to it 4 rectangles that are 22 by 3. And then we're going to subtract from that the 2 circles. So 2 times pi r squared. So we'll plug in for that circle piece, but we need to first identify what our radius is. So if our diameter was 8 inches, our radius is just going to be that diameter divided by 2. So we'll plug in a 4 for our radius. So we can simplify some of this as we're going. So 22 times 22, and then times 2 is going to be 968. Plus, and then 3 times 22 is 66. 66 times 4 is 264. And we'll minus from that the pi times 4 squared. Okay, so we have 968 plus 264. And if we calculate those circles we're subtracting, we should get 100.5. So your surface area is going to equal 1,131.5. So therefore, the surface area of the washing machine door is 1,131.5, and this was in inches, so inches squared. Okay, so remember for surface area, we need to identify the area of each of the two-dimensional shapes and then add them together. That's our surface area for our 3D shape. Okay, that's it for your notes for today. The sheet you'll be able to use for this unit, it has the formula for perimeter and area of some of your common shapes, as well as the surface area and volume of some of your common 3D shapes. So it's important to understand where all these variables kind of come from, and I'll refer back to this today during the note to help you understand where some of the components of each formula come and see if we can have a look. So our triangular base prism is right here. All right, and if you look, in order to find the total surface area, you're going to take two areas of your bases, which my base is that they say B times L because it's the leg of the triangle, and they refer to the height as something else, so that's why they call that the leg, just so that you're not confusing those two H's. So you're going to take two of your areas of your base. Well, you can see here that that becomes just B times L, because if we have BL divided by 2 and then we multiply that by 2, right, because there's two triangles, those cancel out. You're just left with the B times the L. Okay, and then you're going to add to that the area of all your rectangles. So in the case we just looked at, all the rectangles were the same. But if they're different, then you have to make sure that you're calculating that area. So you could have, if all of these sides were different, right, you could have A times H as one of your rectangles, B times H, and then C times H to show you all those three different rectangles. So you're going to add to that all your rectangles, and that's what is represented here. Okay, so again, you could just refer back to this formula if that's easier than the net for you. We are going to look at the next example, which is a cylinder. So while we're on this page, let's look at this formula. So again, whenever we're trying to find the surface area, we have to find the area of all the sides. So for my cylinder, we're going to find the area of our base, which is pi r squared, because our base is a circle. And there's two bases, because there's one on the top and the one on the bottom. So we're going to do 2 times pi r squared. And then the lateral surface, so this curved side here, okay, to find the area of that, you're going to do 2 pi r times h, okay? And there's a whole reasoning beside it. You'll notice that 2 pi r, that's the equation for the circumference of the circle, and basically the circumference of the circle is the same thing as the width of the rectangle. Okay, so you guys don't need to know all that for that. We'll just talk about this formula for here. So the area of that lateral surface is going to be 2 pi r h, so that's what gets added. So we're going to use that formula